So let's draw this system. We have some water here, and we have the mass of the wood here. We'll denote it WO, and then we have a string with a mass connected, and this will be the mass of the lead. So we'll just say mass of PB, sub PB. We know that the mass of the wood is going to be equal to 3.65 kilograms. And we know that the density of the wood is going to be equal to the specific gravity of the wood times the density of water. And this is going to be 0.5 times 1,000. So the density of the wood is going to be 500 kilograms per meter cubed. And we need the mass of PB needed to sink. So at this point, we know that the buoyance force is going to be equal to the density of the wood, density of the water rather, times the volume of the wood times G, plus the density of the water times the volume of the lead, G. We also know that the total weight is going to be equal to the mass of the wood times gravity plus the mass of the lead times gravity. So essentially, when we can set these equal to each other. So F, the buoyancy force, will be equal to the weight, the total weight, rather. And we can eliminate all of these gravity terms because the gravity term is present in every single one of these terms. So we can simply say that the density of water times the volume of the wood plus the density of the water times the volume of the lead is going to be equal to the mass of the wood plus the mass of the lead. We can then solve for V sub these volumes here and say that this is going to be equal to the density of the water times the mass of the wood divided by the density of the wood. And then we'll have plus the density of the water times the mass of the lead divided by the density of lead, which is known. And then this is going to equal the mass of the wood plus the mass of the lead. Through essentially a lot of algebraic manipulation, we find that the mass of the wood times the density of the water minus the density of the wood minus 1 is going to equal the mass of the lead times 1 minus the density of water divided by the density of lead. Once we have this, we can solve for the mass of the lead. So the mass of the lead is going to equal, so this will be the mass of the wood times the density of the water divided by the density of the wood minus 1. And then we have 1 minus the density of water divided by the density of lead. So this is going to equal 3.65, and then we have 1,000 divided by 500 minus 1, all divided by 1 minus 1,000 divided by the the density of lead is going to be 11,350 kilograms per meter squared. And so we find that the mass of the lead needed in order for this block to sink is going to be exactly 4.00 kilograms. And this is your final answer. That is the end of the solution. Thank you for watching.